The quadratic formula. Our objective is to solve quadratic equations using the quadratic formula as well as classify roots using the discriminant. Who uses this? Firefighting pilots can use the quadratic formula to estimate when to release water on a fire. Let's start by looking at where the quadratic formula comes from. Numbers are found on the left and an algebraic form is found on the right. When you're trying to figure out where that quadratic formula came from, all they did was solve for x. So even if it had numbers in it, or just algebraic variables, either way, you're solving for x, and that's where the quadratic formula came from. So you'll see down on the right, this is the one we're going to be using because our a, b, and c values are going to change. This is like an example of a, b, and c, and one way it could come out. The quadratic formula. If ax squared plus bx plus c equals 0, and a cannot equal 0, then the solutions or roots are x equals the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. So once again, the quadratic formula is when x equals the opposite of b plus or minus square root of b squared minus 4ac, all divided by 2a. And it was the equation in standard form where you simply solved for x. Alright, so quadratic functions with real zeros. So if we look here, once again, our quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. So let's start substituting in our values. So our opposite of b would be negative 10 plus or minus, and then we have the square root of b squared, so 10 squared minus 4 times a times c, all divided by 2a. And in case you're having trouble, you can always go through and label. So your coefficient to x squared is 1, so that's your a, your b, and your c. Now let's simplify. Simplify what's underneath the square root first. So we have 10 squared, which is 100, and then negative 4 times 1 times 2 is negative 8. So we have negative 10 plus or minus the square root of 100 minus 8, which is 92. And 2 times 1 is 2. Alright, so now let's put this in simplest radical form here, since we can simplify the square root of the square root of 92. So we have negative 10 plus or minus, and we can split 92 into 4 and 23. So if we split this into 4 and 23, the square root of 4 is 2, and 23 we can't do anything with, since that is already in simplest radical form, and 2 stays on the bottom. One last step. You have a binomial. You can divide the negative 10 by 2, which leaves you with negative 5. And you can divide the 2 square roots of 23 by 2, and that leaves you with simply the square root of 23. So your end result is negative 5 plus or minus the square root of 23. Let's try one with complex zeros. The formula is the same. It's still the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. So the opposite of b plus or minus square root of b squared minus 4ac all divided by 2a. And now we just simplify. So we have 1 plus or minus the square root, and we have negative 1 squared, which is simply 1, and we have negative 4 times 4, which is negative 16. So we have the square root of negative 15, all divided by 4. Well, we can break the square root of negative 15 so that way we don't have a negative underneath. So we can rewrite this as 1 plus or minus I square roots of 15 divided by 4. And since you can't simplify this any further, I'm alright if you leave it this way. Alright, so now let's look at the discriminant. The discriminant of the quadratic equation ax squared plus bx plus c equals 0, where a isn't 0, because if a is 0, you no longer have a quadratic. So the discriminant would be b squared minus 4ac. Essentially, your discriminant is what's underneath the square root. It makes sense because if what's under the square root is negative, you're going to have a non-real solution. Whereas if it's positive, you're going to have multiple solutions, and then if it's 0, there's only going to be 1 because it's going to touch the axis one time because it already equals 0. You can think of it as if you were to have done the quadratic formula here. If you add or subtract a 0 value, it doesn't change anything. So hence why there'd only be one distinct real solution if it equals 0. But if you notice, what's underneath the square root here gave you negative 15, so you have a non-real solution. So if it's greater than 0, you have two distinct real solutions. If it equals 0, you have one real solution. And if it's less than 0, you have two non-real complex solutions. So let's practice. So we have b squared minus 4ac. You might want to put your negative 7 on the other side before you keep going. So we have x squared minus 6x plus 7. You don't want to accidentally take a minus 7 because it will change things. Alright, so b squared, so we have negative 6 squared minus 4 times a times c. So we have 36 minus 28, which equals 8. So since 8 is greater than 0, you have two real solutions. Let's try this next one. So let's rewrite. So we have x squared minus 6x plus 9 equals 0. So we have negative 6 squared minus 4 times a times c. So we're still left with 36 and negative 4 times 9, so minus 36, and hey, that equals 0. So since 0 equals 0 is not greater than or less than, you end up with one real solution. Alright, let's try this next one. I'm sure you can probably take a guess since we have two of the three possibilities already tried out, but let's double check to make sure. Once again, make sure you have everything off to one side and equaling 0 before you go on. So we have negative 6 squared minus 4 times 1 times 11. So we have 36 minus 44, which equals negative 8. Well, negative 8 is less than 0, so you have two non-real solutions. And that would be the discriminant. Alright, so now let's look at an aviation application. The pilot of a helicopter plans to release a bucket of water on a forest fire. The height y in feet of the water t seconds after it is released is modeled by this function. The horizontal distance x in feet between the water and its point of release is modeled by x equals 91t. At what horizontal distance from the fire should the pilot start releasing the water in order to hit the target? Well, let's start by using the quadratic formula. So in case we've already forgotten, it's the opposite of b, plus or minus square root of b squared minus 4ac, all divided by 2a. Alright, so we have the opposite of b, plus or minus the square root of b squared, which is 4, minus 4 times a times c, all divided by 2 times a. Well, when we simplify this, you'll end up with 2 plus or minus the square root of 32,004 divided by negative 32. Now, you're going to do this whole entire piece out with plus and then do the whole piece out with minus so you get both of your responses. So when we go through, we end up with t being about negative 5.65 or t equaling about 5.53. We're not done yet. We still need to take into account when you're releasing the water. So we have x equals 91t. Would it make sense to multiply by a negative number or a positive number for this problem? A negative number wouldn't work because it's trying to tell you that your time is negative. You can't have a negative amount of time. So let's look at our positive number. So we're going to use a different color. So now we have x equals 91 times 5.5, which then gives you 500.5. So the water will have traveled a horizontal distance of about 500 feet. Therefore, the pilot should start releasing the water when the horizontal distance between the helicopter and the fire is about 500 feet. This next piece is just a summary. So, a summary of solving quadratic equations. You can use any method to solve a quadratic, because no matter which method you choose, you'll get the same answer. Sometimes it's simply easier to do one than another. You can graph, you can factor, you can use square roots, you can complete the square, or you can use the quadratic formula. Every time you do one of these, you will get the right answer. Sometimes when the problem is really easy to factor, that's going to be the faster method of solving. But if it's really ugly, you might want to use the quadratic formula because factoring might not work out in your best interest in terms of time.